Okay, good. So I kind of wanted to synopsize what we were doing yesterday with this little handout here. I was going to make it an in-class quiz like I sometimes did in 243, and we'll continue to do that like we did in 243, but I want to kind of have you keep this. I didn't want to take it right away from you, so it's more like just an activity for us to do together, plus I didn't want you writing all this data down. So I had some old data. From January 2010, speaking of economic booms and busts and things like that. This was right at the beginning, if you will, of the collapse after the crazy building boom that Ben saw. And I've lost the source for this one, unfortunately, but I've got sources for the more current data here. Back then, we had a random sample of 702 for-sale Ben homes. I tried to keep it fairly consistent. Just the homes that are on the market at the given time. Not the ones that had sold, or the ones that were owned but in foreclosure, but these were offered for sale. I get this data from real estate sites. 65 of the 702 were in foreclosure. Nice random sample using Remax's, whatever that realty.go Ben, blah, blah. There's a big MLS database I can pull from. So if I want to know, of all for sale homes in Bend, what percentage were in foreclosure, how could I get a reasonable estimate of that percentage? So I'm going to be able to report to the bulletin, perhaps, or news sources, that this percent of homes is actually in foreclosure overall. Now you know right away I can't just come out and say this percent. What do I have to give as a correct statistical answer? I've got to give a margin of error with that percentage, right? Let me make this bigger so the camera will see it. So we're going to have to build ourselves what's called a confidence interval. We were talking. Go ahead and grab that. We're going to have to build a confidence interval around this. Let's take the raw data up here, what we've got. So this is January 2010. You've got a sample, 702 homes. That's what we call little n. 702 homes. We've got a number of successes. Now we call it success just because it's what we're interested in. Being in foreclosure is hardly success, but nonetheless it's what we're interested in right now.
It could be a success.
Well, it could be. It depends. But in general, it has a negative connotation. But it's a success for us because we're interested in that idea. So there are 65 of them. 65 foreclosed homes. Susie?
Do you need a sample of at least 1,000?
Can we come back to that? Susie asked a fantastic question. Don't you need a sample of like 1,000 and some to get? You don't. You need a sample of 1,000 and some for certain constraints, which are not specified with this. All I want is 95% confidence. Does anybody remember that magical number 1,068 from yesterday's class?
Yes.
95% confidence and no more than a what?
3%.
3% maximum margin of error. This just says I just want an estimate with a margin of error, but I'm not specifying a maximum of 3%. Now we know if we got a 1,068 in the sample, we could guarantee no more than a 3% margin of error. And that'll come back to visit us at this problem. Thank you for that. It's fantastic, actually. Cool. So this is all you have to extract. This is all you need to get a 95% confidence interval for the percentage of foreclosed homes. Everything, because you can get p-hat from this. We'll let technology do it for us. We did it manually. You guys didn't seem to care for that too much. Totally fine. That over that is p-hat. That's the percentage. And then the margin of error is a direct consequence of that as well. So let's practice getting it, and more importantly, interpreting it. That's what I really care about. The computation, the manual computation, I'm not interested in. I'm interested in you knowing what it means. So let's do it. Remind me how to get to it on our TIs. Let's make sure this is visible too. Oh, that's not bad. What do you think?
9%.
Stat. Kara, you already got it.
Yeah,
Stat tests.
A. Most of us.
Exactly. A. That's true. A for most of us. Lindsay, we got you squared on your 89, right?
Yeah,
Anybody got an 86 that we're still using? Because 86 is in a slightly different place, Paris. You have to go into something I installed into there. Remember how to, it's math, then stat, it's in there. And yours, I believe, you have to go to more until you see, I think it's called 1PIN-Z. 1PINZ. It's very, very small, but just keep scrolling through until you find it, my friend. Here we are. Let's figure out what it is. X is 65 out of 702 with 95% confidence. So this is where Karen said 9.3%. That's the p-hat value. That is 65 over 702. is 9.2%. Everybody solid with calling that 9.2%? It's a decimal, but it's 9.2%, or 9.3, I guess, 9.3%. Why can't we just say, well, the percentage of foreclosed homes in Bend is 9.3%? Why can't we just say that, Ashley?
We don't know where that number falls in the bell curve of the population.
Very nice, very nice. Ashley's talking about bell curves. Makes me so happy. Okay, I'm going to slide over to the sideboard. I wasn't even thinking that, but this is 100% correct, Ashley. So check it out. This bell curve is the sampling distribution of the experiment you just did. In the middle of that bell curve, is little p. Now, not p hat, little p. Little p is the proportion of foreclosed homes in Bend. Do you know what that is? You do not know what that is. Hence the point of doing this experiment, trying to figure out what it is. What Ashley just said is so perfect. You got a p hat value. Your p hat value fell somewhere on this curve. What's the chance it fell right there? Essentially 0, right? The chance it fell exactly on p is essentially 1 in infinity, because there are infinitely many places it could fall. What's the chance of it falling? Now, it's more likely to fall on p than it is to, say, fall in these ends, unless you got outlier data. But chances are you fell somewhere off of p a little bit. Chances are you fell somewhere off of p. So you can't come back and say it's 9.25% or 9.3%, because it probably isn't. So what adjusts for this potential offness?
Margin of error.
We put the margin of error on that, and that 95% of the time, hence 95% confidence, will be wide enough to include the value we're looking for. Does that, you guys buy that? Does that make sense? So that's why p hat, yes, does not necessarily equal little p, which is what you're looking for. Unless you're really, really lucky. But even if you're lucky, you won't know it. You won't know that you're lucky, even if you are lucky. Fair enough? Ish? Okay. The idea, though, is you don't need this. What you're hoping, see if you buy this symbolically, see if you buy this. You're hoping that that value of little p that you're looking for is between p hat plus that margin of error. I was using MOE, wasn't I? Yeah. MOE and p hat minus that margin of error. See, this is a little bit algebra-y, but not really, because we're done with it at this. This is just symbolic, really. You're hoping with 95% confidence that what you're looking for, little p, the unknown, is between the low and high end of your confidence interval. So although you don't know where p is, you are 95% confident that it is at least about 7.1% foreclosure, and at most 11.4% foreclosure. And that's why the margin of error helps. Yes, as Ashley eloquently pointed out, p is in the middle. But by stretching a margin of error around p hat, 95% of the time, you pick up the p you're looking for. Is that fair? That's what a confidence interval is. It's the admittance that, yes, there is a curve of the sampling distribution around the parameter that you're looking for. And that sampling distribution represents all possible values of p hat that you might get based on your sample data. We did this at the very end of 243 when you guys were rolling dice and drawing your bell curves up on the board. Remember those beautiful bell curves you had?
Yep.
They were centered on the averages. Even though you didn't know what the averages were, they were centered on them. But sometimes you were off average. You were too high or too low. But as soon as you stretched out the standard error, 2 standard errors to make a margin of error, you were gobbling up the average, on average, 95% of the time. That's what's going on here. So you can say, with 95% confidence, I am 95% confident that the rate of foreclosed homes for sale in Bend is at least 7.1% and at most 11.4%. How's that? 95% CI, confidence interval, 7.1% up to 11.4%. Now I put a number line at the bottom of your page there because I like a visual. I like a visual of the number lines. So I'm going to go ahead and let's put that, we'll put it over here, I think. Put it over here. Put 0 down here. I think I have 12 up here with 6 here. 9, 3. So 7.1 to 11.4 is going to be something like this-ish. And there's January of 2010. There's January of 2010. Remember the fish in the tank? From yesterday, fish in the tank? The leftmost the fish can swim is down to about 7.1%. The rightmost the fish can swim is about 11.4%. There's your 95% confidence, the width of that tank. If you want to be more confident, make the tank wider. But let's stick with 95% confidence for reasons that will uncover themselves as we go through the course, I promise you on that. What does the fish represent in that tank? This is something I learned from my last period, my last class, last term. I kept using the fish analogy without revisiting what the fish was each time, and I think it was confusing some people. Christian, the fish is little p. The fish is the parameter you're looking for. So when you build the interval, the fish swimming back and forth represents the unknown position of the parameter you're looking for. But with 95% confidence, he's somewhere in the interval you just built. He's somewhere. Does this mean you're going to miss it every once in a while? Yes, 1 in 20 times on average, you're going to miss the value. You're going to create an interval that's too far to the right, that even with a margin of error, it will miss it, or too far to the left, that even with a margin of error. But what do we call those data points that are too far right and too far left?
Outliers.
Outliers, because they don't happen very often. They're unusual. Usually, as actually, what you said earlier actually was perfect. Usually what happens is we end up with values that are close. And close statistically means within a margin of error. So that's what we're happy about. I don't know that it's 9.3%. As a matter of fact, it probably isn't 9.3%. But I can be 95% confident that it's at least 7.1 and at most 11.4. Is that fair? Susie asked me that question. Yes? Ask me that question.
Oh, I have a question.
You have a question, I'm saying, ask it. Oh.
Sorry.
No, I want to hear.
So would the margin of error then be the difference between the two divided in half?
Yes, that's my next question actually, was what is that numerical value of the margin of error? The TI does not give it to you directly. But Susie just told us how to find it. Because of this, because the confidence interval is p hat less the margin of error up to p hat plus the margin of error. There are two margins of error in a confidence interval. P hat down and p hat up. So how far are they apart, ish? 4.3 it looks like percent? So that's two margins of error. So I'm guessing 2.15% margin of error is what that is. 2.15% margin of error, ish. So if you were reading this in a poll, the poll would probably say 9.3% homes in foreclosure, in bend, which you would say, And then at the bottom of the poll, you'd see plus or minus 2.15% margin of error, and then you'd say, okay, I'll let you slide on that one. Even though the headline's wrong. Since the margin of error is there, we'll let it slide. I want to go back to Susie's question, though. That's a 2.15% margin of error. Remember what I did? She asked a great question before. Wait a minute, there's not enough in the sample. There's not enough in the sample. If you have 1,068 by sample size count, we can guarantee a maximum of 3% margin of error and 95% confidence. Well, how is it? How is it that we have less than 1,000 and yet we still have a margin of error less than 3%, Michael?
Is it because of the ratio between the two numbers?
Yes, it's because, and this is a mathematical kind of issue. This is one of the things I want to put in that YouTube video. The derivation of that sample size calculation assumes the most disparate values of p hat and q hat. And those most disparate values are 0.5 and 0.5. The more skewed you get away from 0.5 and 0.5, the smaller the margin of error gets by the definition of what the standard error is. So since p hat is only about 10%, the product of 10% and its q hat of 90% is 0.09, not 0.25. And that's why the margin of error actually shrinks down. The further p hat gets away from 50-50, the smaller the margins of error get as a consequence of the mathematics of the standard error. So when you're starting the problem, you would say, oh, I need 1,068 to guarantee a maximum margin of error of 3%. But that's a worst case scenario, assuming that p hat comes back at 0.5, which is a coin flip, basically. This is why so many Gallup polls sample over 1,000 people, because presidential approval ratings are always hovering around 0.5. They're hardly ever down at 0.9 or 0.05, or 0.09 or 0.05 or something small, or something very huge. So they sample more. Now, of course, if we had done this study with 1,068 versus 702, what would have happened to our confidence interval? What would happen to our confidence interval?
Shrink.
Wouldn't it do this? Wouldn't it have to do this? Because, exactly, you read my mind. Because Ashley's awesome little curve over there that she talked about, wouldn't look exactly like that if we sampled 1,000 versus 702. It would look more like that. It would look more like that. And everything would proportionally change because of that. So your margin of error would actually go down. Michael, go.
By contrast then, if we had like 702 for n and let's say
300?
Exactly, we would have a huge margin.
Yes.
Okay.
Michael's question is, suppose there were more houses in foreclosure than 65. Yes, the margin of error will commensurately get larger due to the function of the margin of error. Yes. Great questions, great questions. Cool? Susie, does that answer your question about the 1,000 from yesterday? It was a great question. It's one of those things you should be asking yourself. But it's a function not just of the sample size, but also of the behavior of the results you get, which is very interesting. Proportions are the only ones that have that, because all you need are these two parameters. When we start doing continuous data in a little bit after the break, you're going to see that you also have to have a standard deviation, not just an average. This is basically an average. You also need a standard deviation, and we'll talk about that after the break. Cool? Fair?
Do you want to move your camera?
I will eventually. I'm loud enough, I think it's picking me up right now on the mic. So what I want you to do is to go back to your little handout there, and I put in parentheses and italics, does this satisfy the requirements for a 1 prop z int? Or does it satisfy the requirements for estimating a proportion on a population?
Yeah.
This is not the kind of thing I ask you on in-class assessments on your time, because I don't want you keeping this stuff memorized in your head. But what was the big checklist? What kind of data did... Go ahead, Beth.
Well, it has to be binomial.
It has to be binomial. Excellent. Is this data binomial?
Yes.
Yes, with a fixed number of trials. 702.
There's 2 outcomes.
There's 2 outcomes. Jessica, either...
I don't know.
Right.
Yes.
Either they're foreclosed or they're not. Love it. We're assuming that each of the data points is independent of either data point. So we got independence, we got binomiality, we got a fixed number of trials. Good. Other ideas. What does Christian go?
Enough data to have a bell.
Nice. Enough data to kick in the bell. Now, Christian, I love that you brought that up. That was fantastic. This is tricky because the enough data to have a bell requirement is that n times p and or n times q have to be at least equal to 5. That's enough data to get a bell. Now here's the problem with this. What is P? We have no idea what P is. But we have to make sure that whatever our sample size times P is bigger than 5. At that point you go, holy crap, how do I know this? Well, there's 2 workarounds for that. Number 1 is run sample size calc. That's built into sample size calc for you. Another one is just to assume that P is something ridiculously small, like 1%. If P is 1%, which it didn't come out being. It came out being much higher. But if P is 1% completely skewed, then 700 times 1% will give us 7, which is bigger than 5, which means we have enough data to get that bell, even at a little tiny proportion of 1%. Chances are you're not going to get a little tiny proportion of something like 1%. So that's why I love what you said, Christian, enough data to get a bell. Please do not worry your minds about this. Use the sample size calculation program that I gave you instead. Okay? But Christian, you're right. We have to make sure that Ashley's bell she mentioned is actually there. But we've got it. We've got it checked off. We've got it checked off. Is that fair? You guys buy that? They good? Okay. Now, I mentioned before, I'll get this out of the way so it doesn't confuse us. Slide this back. There we go. How's the battery? Okay, good. I apologize for those of you looking at the videos and having my nose in the camera every 20 minutes or so to check on things. An indicator, there's all kinds of economic indicators. The recession is over. The Great Recession of 07 and 09 is over. You heard, right? The Great Recession is over. 07 and 09 is done. So there are many, many economic indicators for measuring whether or not a recession is over. I don't understand many of them. But since I was using this data a few years back in class, I decided to check an update of it. So here, I used a couple sites to collect some data for us. In April 2013, I got a random sample of about 1,734 for-sale homes. Now, when I say this is Bend, these regions go out into basically central Oregon. I believe it's like Deschutes County and maybe even some of the neighborhood. So all of this is, I'm saying Bend, it's not exactly Bend, it's Bend-ish. Okay? So I got 1,734 homes. So Susie, I'm feeling better about this. I got 163 of them that are in foreclosure now. Okay, so now let's re-answer Oh, I have a typo here too. Let's re-answer the question we did in the first one. It says, what percentage of all Bend for sale homes were in foreclosure in, that should say April 2013, not January. I copied and pasted and forgot to update. So let's do the same thing we did in the first one, but for April 2013. And let's see if that tells us anything. So we're going to run the exact same computation we just did. The exact same computation that we just did. Stat tests A. Except we're going to run it on 163 homes out of 1,734. Say that again. Excellent. Beth is already on it for us. Good, very, very good. You guys are always a couple steps ahead of it, which is fantastic. So we're going to rerun it. Notice P hat, 9.4%, which is essentially the same 9.3% as it was in 2010. But look at what's a little bit different, friends. So now we're in April 2013, okay. Our 95% confidence interval for foreclosed homes now appears to be about 8% up to about 10.8%. And this is why I like slapping that on the same number line as the previous one, to compare them. They have almost the exact same center, which I was kind of hoping they would. Because I wanted them to kind of line up symmetrically. So 8% is going to be ish here, whereas 10.8% is going to be ish here. So here's April 2013. So they have almost the exact same p hat value. Almost the exact same p hat value. Why is it that if they have the exact same p hat value, that interval is so much more narrow? And I say so much more. It's just, I shouldn't say that. It's more narrow. If they have the same p hat, why aren't they the same interval, Karen?
You have a larger sample.
The sample size is larger, which, as we've been talking about, drives the margins of error down. As a matter of fact, if you could let the sample basically go off as high as it could to get the population, you wouldn't need an interval because there wouldn't be a standard error anymore. And that's exactly what it is. So now you can be more precise with your answer. In April 2013, based on my random sample, 95% confident that between 8 and 10.8% of homes are in foreclosure. So, could we make the claim that there is a different number of houses in foreclosure now than there were in 2010? No, because it looks like we can't tell. Could there be a lower percentage rate now than in 2010?
Yes.
Could there be a higher rate now than in 2010?
Yes.
Could it be the same rate now as in 2010? The problem is the fish. There is a fish, a 2013 fish in that orange tank, and there is a 2010 fish in that black tank, and they're going like this, and you don't know where they are. It's possible that orange fish is over here, and black fish is over here, and the actual percentage of foreclosed homes is higher now than it was then. It's also possible that this is the situation. So right now, percentages are lower than they were in 2010. It's also possible they're both the same at any point along. And the problem is you don't know where the fish is. If that range is too wide, go get more houses in your sample. Go ahead, Beth.
That's what I was going to say. With the sample size change because it's 2013, there's been more houses built, so you really couldn't say.
Well, more houses built, but also I just cast the net wider this time. I was just able to cast the net wider. More houses built, but I wonder, and the answer to this could be yes. Essentially, I doubled the sample size from before. There aren't twice as many houses in Bend now as there were in 2010. There are more, but I just cast the net wider. I was able to get more data this time. I'm not taking credit for that. I was just able to get more data this time. Cool?
We're not going to have a fight.
No. Your point is a good one. And suppose I cast the net even wider.
Yeah.
Now, Spencer asked me a great question yesterday. If I cast the net so wide that I actually measure all houses, then the margin of error becomes irrelevant. Because if I've measured all houses, I am no longer talking about p hat.
Right.
I'm now talking about p. Which means this whole argument goes out the window because then I know the answer. What's the percentage of houses? 7.16%. I measured every single one. You could actually do that in a town the size of Bend with enough resources. That's the kick, of course, is enough resources.
You could really narrow it in if you did like certain areas.
Exactly, friend. That's why I can call your guys' test averages mu in this class, because there's only 40 of you. I can actually measure them all, put them in an Excel grade book, and call it mu as the average. Chris, go ahead.
Well, you got 1,734 houses for sale.
That's what I'm comparing.
So you're gonna
apples,
have
apples.
houses that are for sale.
Exactly. But I only sampled from within those for sale, and I'm talking the net was pretty wide because of that. I want to look at for sale houses. I was trying to keep apples whenever I could. Okay, we could also do all homes in the market. The trick, and you guys keep this in mind as you go, if you're starting to do your own kind of data mining, the trick is the definition of apples. When you go to a real estate site, they have really good filters nowadays. Check foreclosed, short sale, still occupied, unoccupied for 6 months, unoccupied for a year. A lot of those things are overlapping. For example, foreclosed, occupied for 6 months. That could be the same house in both of those. But the filters are getting pretty smart in that they don't double count anymore. So just be aware of those kinds of things. Like I didn't know that foreclosed and short sale were two different things necessarily until I started looking at the definitions yesterday. I'm like, oh my god, they are. I thought they were the.
House hunters?
No, I have a 5-year-old. I don't watch TV. I'm lucky to sleep 5 hours. Please, Paris.
So, I was going back to like, just measuring every single thing so that you don't have a margin
Yes.
of error.
Yes.
So what if you did something besides like foreclosure where you need more resources, like going back to, for example, like the penny experiment where you actually can, even though like you can spin the penny more times.
Yes.